Welcome friends, in this video let's discuss about greenhouse gases which are responsible for the global warming and greenhouse effect, and one important concept called global warming potential, which is also related to these greenhouse gases. So there are important greenhouse gases which are present in the atmosphere. These include water vapor, carbon dioxide, methane, nitrous oxide, fluorinated gases, black carbon and brown carbon. For the previous videos related to climate change and global warming and greenhouse effect, please visit my previous videos and come back here if you have not watched that. It makes sense. It gives you conceptual clarity as we proceed through the video. And again, coming back to the greenhouse gases, I'm going to discuss this one by one. First, water vapor. This water vapor is the biggest overall contributor to the greenhouse effect, okay, not the global warming. Okay, water vapor is the single biggest contributor to the greenhouse effect, which keeps the earth warm, okay, which provide enabling condition for the growth of living beings on the earth. Okay, and this water vapor is not a threat to global warming because it has short life cycle and it is part of the normal water cycle, that is biogeochemical cycle. This water vapor is produced by the evaporation of water from the earth sources like ocean and water bodies to the atmosphere. These water vapors in the atmosphere in the over a period of time condenses and forming clouds, and these clouds gives back the water to the again earth's environment in the form of rain. Okay, so this cycle continues in the form of evaporation and precipitation. So this water vapor is part of this water cycle, and this is, as I mentioned earlier, this is not a threat to global warming because it has very short life cycle. Only 1 or 2 weeks, 7 to 14 days is the life cycle of the water vapor. So the cycle goes on like this. But in contrast, the carbon dioxide has the life cycle of more than century. So if you release carbon dioxide molecule into the atmosphere, that will remain in the atmosphere for more than 100 years. So this is causing the global warming. So carbon dioxide concentration goes on accumulating in the atmosphere and causing global warming. So this is the thing about water vapor. So water vapor creates greenhouse effect but not the global warming. Please remember here. And next important greenhouse gas is the carbon dioxide. Carbon dioxide is the primary greenhouse gas emitted through human activities. We know that carbon dioxide is the single biggest primary greenhouse gas which is causing global warming, and it is also a part of the carbon cycle. As I discussed in my ecology videos, carbon cycle is an important cycle for the sustaining living beings on the earth. And if you interfere in the normal balanced carbon cycle with various human activities like deforestation, emission of fossil fuel gases into the atmosphere, or other industrial activities, that is leading to destabilization of the biogeochemical cycle, that is the carbon cycle. And this is leading to various undesirable events like global warming, climate change. Okay, so this is a classic example of the interference of human beings in the normal biogeochemical cycle and the resultant effects on the ecosystem as well as the living beings on the earth. Okay, this is the carbon cycle, and various human activities are adding carbon dioxide to the atmosphere. The sources of the carbon cycle includes the sources of fossil fuels which are used for the transportation, for various activities like for utilizing the cars, public transport and other things, and for the production of electricity in the form of thermal power plants by the utilization of coal. So burning of coal also adds carbon dioxide to the atmosphere, and various other industrial processes like production and consumption of mineral products such as cement. Cement production also contributes carbon dioxide to the atmosphere, and the production of metals such as iron and steel and production of chemicals also contributes carbon dioxide to the atmosphere. And these sources are increasing the carbon dioxide, and carbon dioxide in turn is resulting in the global warming. So this is one of the biggest gas which is contributing to the global warming. And next thing is methane. So methane is emitted by natural sources such as wetland, as well as human activities such as leakage from the natural gas system and raising livestock. So this wetlands has a particular situation where wetlands do not have the normal oxygen content. So the microorganisms present in the wetland are sustaining in anaerobic condition, that is the absence of oxygen. These anaerobic bacteria are releasing methane to the atmosphere through anaerobic chemical reactions. So this is the thing. And the paddy fields is one of the largest emitter of methane to the atmosphere. So agricultural operation is also one of the emitter of methane to the atmosphere. This paddy field is the main emitter because paddies are grown in anaerobic condition, that is in standing water. So this anaerobic condition is also contributing methane to the atmosphere. And various natural processes in soil and chemical reaction in the atmosphere helps the methane to be removed from the atmosphere. So that is another part. And as I mentioned earlier, various natural events like wetlands and the waste products from these animals, that is the dung and urine, also contribute. Breakdown of dung and animal urine also contribute methane to the atmosphere. This includes livestock, that is cattle, buffalo, sheep, goats, and camels, and various industrial activities like natural gas, crude oil, various production chain of crude oil, including production, processing, supply, and transportation. So storage and transportation activities also contribute methane to the atmosphere, because methane is one of the important contributor of natural gas, constituent of natural gas. And various waste materials also contributes methane to the atmosphere, including landfills. So landfills also contributes methane to the atmosphere, and wastewater treatment also contributes methane. So these are the different sources of methane. And remember, please remember here, the paddy fields as well as animal husbandry, that is the domestication of cattle, buffalo, sheep, goats, and camels, also contributes methane to the atmosphere. These are the two important sources of methane agriculture operations emission into the atmosphere. And next important gas is nitrous oxide. This nitrous oxide is naturally present in the atmosphere as part of the Earth's nitrogen cycle. So this nitrous oxide is not per se causing global warming, but unsustainable release of nitrous oxide into the atmosphere by human activities is causing global warming. Okay, and various natural emission of nitrous oxide are mainly from the breaking down of nitrogen in the soil and oceans by various soil bacteria. It's also contributing nitrous oxide to the atmosphere. This is a natural source, but human actions, including in the agriculture operations, that is we use nitrous oxide and various nitrogen fertilizers to the crop for better yield of the crops. So synthetic fertilizers are contributing the nitrous oxide, and livestock manure also release nitrous oxide to the atmosphere during the breakdown. Okay, and during transportation, fossil fuels also, burning of fossil fuels also contribute nitrous oxide to the atmosphere, and various industrial processes also contributes nitrogen. This include nitrous oxide is generated as a byproduct during the production of nitric acid. So this nitric acid is used in the synthesis of commercial fertilizer, and also nitrous oxide is produced in the production of adipic acid. Okay, adipic acid. This is used in the making of various fibers, including nylon and other synthetic products. So these are all the sources of nitrous oxide to the atmosphere. And next important greenhouse gases are fluorinated gases. They are emitted by various industrial processes. These include aluminum and semiconductor manufacturing and substitution. And these fluorinated gases are used as a substitution for ozone depleting substances. We know that chlorofluorocarbons are used for various industrial activities like refrigerant, fire retardants, aerosols. Okay, and these chlorofluorocarbons were causing the ozone depletion. Okay, depletion of the ozone layer. So these fluorinated gases, that is the hydrofluorocarbons, perfluorocarbons, and sulfur hexachloride, are used as a substitute for chlorofluorocarbons, because these compounds has the property of meeting the requirements of fluorocarbons, but they did not deplete the ozone layer. So these fluorinated gases are used to replace the chlorofluorocarbons in the industrial uses. But these fluorinated gases, even though they do not deplete the ozone layer, but they significantly contributing to the global warming. So this is one of the negative point about the fluorinated gases. And this is having higher global warming potential. They have the capacity. Each molecule of fluorinated gas has the highest capacity of causing global warming when compared to various other greenhouse gases like carbon dioxide and nitrous oxide. Okay, and as I mentioned, there are three important categories of fluorinated gases. These are hydrofluorocarbons, perfluorocarbons, and sulfur hexachloride. Okay, and here chlorofluorocarbon and these fluorinated gases are different. Okay, and as I mentioned earlier, these are used as a substitution for ozone depleting substances, as I mentioned previously, but these are significantly contributing to the global warming. And hydrofluorocarbons are used in various industrial manufacturing processes like manufacturing of refrigerants, aerosol propellants, solvents, and fire retardants. And these compounds are very stable, highly stable. They have fire retarding capacity. They do not catch a fire. They are not inflammable, and they are stable. They are environmentally stable, and also they are not reactive with other compounds. So because of these safety things, they are used in the industrial activities, but they are known to cause global warming. That is the negative point about this. And this is used as a replacement for chlorofluorocarbons, as I mentioned earlier. And sulfur hexafluoride is used in various manufacturing processes like magnesium processing and semiconductor manufacturing, and it is also used in electrical transmission equipment including circuit breakers. So these are all the uses of these fluorinated gases. And next important greenhouse gas is black carbon. This is per se is not a gas. Black carbon is not a gas. Please remember, black carbon is a solid particle or aerosol. It appears like this, and this is produced due to the incomplete combustion. Various sources of black carbon are biomass burning, that is the burning of firewood in the rural areas for various activities like cooking and boiling water for bathing and other things, and cooking with solid fuels and diesel exhaust. These are also emitting black carbon to the atmosphere. And the important property of the black carbon is when it is present in the atmosphere, it absorbs the heat directly. Okay, and directly it contributes to the warming of the atmospheric layer. Okay, and when it is present on the surface of the ice, okay, it reduces the albedo. Albedo is the capacity of the ices. Okay, ice, since it is light in color, it reflects majority of the sun rays that reaches on the surface of the ice, because later white colored substances reflect light. They do not absorb the energy. Only dark colored materials absorbs as much energy as they can. But when this black carbon is deposited on the ice surface of the glaciers, that result in the change in color of the glacier, and this result in more absorption of energy from the sun, that is the heat from the sun. This is resulting in accelerated melting of the mountain glaciers. So this is one of the cause. And the role of India in the emission of black carbon is significant, because India along with China is contributing 25 to 35% of the black carbon emission into the atmosphere. And we are using black carbon for various purposes like cooking and heating water, and used for heating of the houses in the China. Okay, and brown carbon. This brown carbon is ubiquitous, that is present everywhere, but it is unidentified compound of organic aerosol, and it is also produced due to soil humic like substances. Okay, this was found in a recent laboratory experiment. And the possible sources of black carbon are biomass burning. The possibly domestic wood burning is shown to be a major source of black carbon, and smoke from agricultural fires may be additional source. Usually the farmers, what they do is after the cultivation of crop, for example sugarcane are cultivated, after the harvest, after cutting of the sugarcane for marketing, all the crop residues are present in the farm itself. Instead of utilizing this as a manure, they are simply burning these crop residues. This is also contributing to the global warming, because it adds more gases to the atmosphere. So this adds brown carbon to the atmosphere. So this is one of the source. And remember, black carbon is a solid particle and brown carbon is a gas. Okay, please remember these two things. Now let's look at the concept of global warming potential. This global warming potential describes the impact of each gas on the global warming. That is the potential of the gas to cause global warming. So there are two important factors which decides the global warming potential of a gas. Okay, and the first factor is the absorption capacity of the gas. How much energy the gas can absorb from the sun or heating sources. Okay, the absorption capacity of the gas. Okay, and longevity of the gas. How long that gas stay in the atmosphere without disintegration. Okay, and these two factors combinedly decides the global warming potential of that gas. See, this global warming potential is the total energy that a gas absorbs over a particular period of time compared to the carbon dioxide. Here the carbon dioxide is taken as a base. Okay, it is taken as a base, and whatever the carbon dioxide, whatever the energy that is absorbed by the carbon dioxide molecule for a period of 100 years is considered as one unit. Okay, and this unit is used to compare the global warming potential of various gases. I'm going to discuss this clearly in the next slide. Okay, the gases with higher global warming potential absorb more energy per pound than the gases with lower global warming potential. So this table clears your doubt about that. And here, for example, consider 1 ton of carbon dioxide for a period of 100 years. Okay, absorb 1 unit of energy, 1 unit of heat. Okay, this is the thing. 1 ton of carbon dioxide for a period of 100 years absorbs one unit of energy or 1 unit of heat. Okay, this causes 1 unit of global warming in the atmosphere. This is considered as a base. Okay, base, and on this base the global warming potential of all the greenhouse gases are calculated. For example, the methane gas causes 21 times more global warming when compared to the carbon dioxide, because it has 21 units of global warming potential. For example, 1 ton of methane that is released into the atmosphere is causing 21 times the heating that is caused by the carbon dioxide. Okay, and nitrous oxide is more when compared to carbon dioxide. So for example, 1 ton of nitrous oxide that is released into the atmosphere is causing 310 times more global warming when compared to the 1 ton of carbon dioxide that is released into the atmosphere. And various fluorinated gases, as I mentioned earlier, these are having higher global warming potential. For example, this hydrofluorocarbon has 11,700 units of global warming potential. For example, this 1 ton of hydrofluorocarbon is contributing 11,700 times more global warming when compared to 1 ton of carbon dioxide. And perfluorocarbon is also has significant global warming potential, that is 9,200. And sulfur hexachloride highest, it has the highest global warming potential, that is 23,900. Okay, that means 1 ton of 1 ton of sulfur hexachloride is resulting in global warming to the rate of 23,900 times that of carbon dioxide. So this global warming potential, when seen in conjugation with the lifetime of that gas, shows the real picture of the potential of that gas to cause global warming. That, for example, the carbon dioxide once released into the atmosphere can stay for more than 50 to 200 years. Okay, the methane only 12 years. So even though the global warming potential of methane is 21, that is 21 times that of carbon dioxide, it remains in the atmosphere for only 12 years. But carbon dioxide remains in the atmosphere for 200 years. So one molecule of carbon dioxide remains for 200 years and causing significant global warming. And nitrous oxide 120 years, hydrofluorocarbons remains in the atmosphere for 270 years without degradation, and perfluorocarbon for 50,000 years, 800 to 50,000 years, depending upon the various factors like because this fluorinated gases, when once released into the atmosphere, they spread throughout the atmosphere. Okay, and over the time they reaches the higher level of the atmosphere till the stratosphere. In stratosphere, the UV radiation, ultraviolet radiation from the sun, breaks down these fluorinated gases, resulting in the end of life for these gases. So till then they will be in the atmosphere in a stable manner. And this sulfur hexafluoride is has a lifetime of 3,200 years. So here, one thing, the sulfur hexafluoride has highest global warming potential, and perfluorocarbons has highest lifetime, okay, 50,000 years. So this is thing about global warming potential. Thanks for watching. Please share this video on Facebook and subscribe to the channel for more updates. Thanks for watching. Thanks for giving me this wonderful opportunity to share my views. Okay, thank you.